Today I will present about my digital key lock by last 4 digits of my student ID. My password is 0132. First, start with pre-processing unit. I have 10 switch 0 to 9. This is my switch. My password is 0132. So we use switch 0, switch 1, switch 2, and switch 3. I give a variable of it is of switch 0 is C0. Switch 1 is C1, switch 2 is C2, and switch 3 is C3. I have a wrong number detect to decrease input and make circuit easier. I connect switch that's not my password by OR gate. It's until switch 4 to switch 9. We OR it together, connect it together with OR gate, and I call it variable of it is M. So we get a total, we have 5 input in the last. After we get a schematic, so next is a equation of it. I give so C0 is switch 0, C1 is switch 1, C2 is switch 2, and C3 is switch 3. Next is wrong detect equation. M is switch 4 or switch 5 or with switch 6 or with switch 7 or with switch 8 and or with switch 9. So we get all of equation of pre-processing unit. It is. Next, I will describe about circuit diagram of this circuit. Start with state 0. State 0 is wait for we push the first of the password is 0. wait for 0 at state 0. When we didn't push or push something wrong, it's still in the state 0. Not 0. And when we push the correct password is 0, is go to the next state. Go to the state 1. State 1 is wait for release from the button. Wait for release. If we still push on the 0 switch off, sorry, it doesn't have bar. 0. And when it's still 0, it will still in the state 1. Push 0 is still in state 1. And when release the button, it will go to the next state to check the next password. We have the if we wrong in this state, it will go to state 0, such as when we push 0 and we push another button, it will go to state 0 because it's wrong in this circuit. It's incorrect. When incorrect, it will go to state 0 to restart it. At state 2 is a wait for the second password is 1. Wait for 1. If we doesn't push the button, it's still in state 2. Doesn't push anything. We use it's N. N is no press the button, no push the button. It will still in the state 2. If we push the wrong password, it will go to state 0. Yeah, incorrect password. If we push the correct password, is go to the next state. Go to the state 3. Oh, sorry. We release and then did. When we push the 1, we go to the next state. This state is wait for release from the button of the correct password. We wait for release. If we still push it, it will stay in this state. Still push 1, it's still in this state. And if it's incorrect, it's go to the state 0. Incorrect. And then when we release it, release is no press. It will go to the next state. State 4. State 4 is wait for the third of the password. The third of password is 3. State 4 is wait for 3. if it still doesn't push nothing, it's still in this state. No push and no push. See, if we push the wrong, it's go to the state 0. Incorrect. And when we push the correct password, it will go to the next state. State 5. Push 3. It will go to state 5. State 5 is wait for release. The button, the 3 button. Wait for release. If we still push, it's still in this state. Still 3. If it's wrong, it's go to state 0. Incorrect. I will change something. Incorrect. When we release the button button 3, it go to the next state. Release is N. No press. Let's go to the next state. Is state 6. State 6. State 6 is wait for push the last of the password. Wait for last word is 2. Wait for 2. If we didn't push it, it's still in this state. No press, didn't push it. If we push it incorrect, it's go to state 0. Incorrect. And when we release the last button, it's go to the next state. It's the state 7. State 7 is wait for. Oh, sorry. At the state 6 is wait for 2. So when if we push the correct is if you push 2, it will go to the next state. Sorry, it's push 2, it's go to the state 7. State 7 is wait for release the button. If we still push 2, it's still in this state. And if it's incorrect, it's go to state 0. Incorrect. And the last state is state 9, state 8. And when we release it, no press, it's go to the last state. It's the state 8. State 8 is LED on. It will show if it's correct. It's correct all of the password is so it's LED. It will show it's you put the correct password. If we still release it, no press, it's still in the state 8 and LED is still on. And when we push something, anything, which I I will give it A. Any button, if you push it, it will go to state 0 to reset the circuit. That is the state diagram of this circuit. Next, I will describe about state table from state diagram. At state 0, it will go to state 1 when you press the 0 button. And other case is still in the state 0. Next, state 1. When you still press the 0 button, it's still in the state 1. And when you release it, it goes to the state 2. Release it is no press. And another case is go to state 0 because it's wrong. Next, state 2. When you my second password is 1. When you press 1, it go to state 3. And when you still release it, it's still in the state 2. And other case is wrong, it go to state 0. Next, state 3. If you still press the button of 1, it's still in the state 3. And when you release it, it go to state 4. And other case is go to state 0. At state 4, when you release the button, it go to the when you release at state 4 when you release the at state 4 when you at state 4 if you still release it, state 4 is wait for the third of password. If you still release the button, it's still in the state 4. And when you press the button T, it go to state 5. And other case is go to state 0. And state 5, if you still push the button number 3 is still in the state 5. And when you release it, it go to the state 6. And other case is go to state 0. At state 6, if you still release the button, it's still in the state 6. And when you press the last password, is button number 2 is go to state 7. Button number 2, state 7. And other case is go to the state 0. at state 7 when you still press the button number 2 is still in the state 7 and when you release it it go to the state 8 and other case is go to state 0 and the last one state 8 when you add this state the LED is still is on and when you press any button when you didn't press anything it's still in the state 8 and when you press any button it's go to state 0 to reset the circuit. That's all of state table. Next is state assignment. State assignment. I will change a variable in state table to binary form to use for making the left block equation. We change state 0 to 0 to 0 0 0 0 state 1 to 0 0 0 1 state 2 is 0 0 1 0 state 3 is 0 0 1 1 state 4 is 0 1 0 0 and state 5 is 0 1 0 1 state 6 is 0 1 1 0 state 7 is 0 1 1 1 state 8 is 1 0 0 0 and then we change all of this table to the binary form. This is all of the state assignment. Before I go to the left block equation, I will tell you press 0, press 0, press 0 is C0 and with C1 bar, and with C1 bar, and with C2 bar, and with C3 bar, and with M bar. M bar is a wrong number. Next, press 1 is C C0 bar and with C1 and with C2 bar and with C3 bar and with M bar. Press 2 is C0 bar and with C1 bar and with C2 and with C3 bar and with M bar. Press 3 is C0 bar and with C1 bar and with C2 bar and with C3 and with M bar. The last is no press or release. No press is the C0 bar and with C1 bar and with C2 bar and with C3 bar and with M bar. Next is the left block equation. Left block equation is to use the min term to design. I will focus on the number one of state assignment. So we got the equation of f0. F0 is a fifth of number 0. F0 is the last, focus on the last digit of these 4 digits. So we get the F0 is state 0 and with press 0. State 0 and with press 0, or with state 1 and or with state 1 and with press 1. Next is all with state 2 and with press. Oh, sorry, this is it's not press 1, it's the press 0. Press 0. Or with state 2 and with press 1, and or with oh, sorry about the accident. We continue the equation. Next is all with the state 3 and with press 1. Or with the state 4 and with press 3. Or with state 5 and with press 3. Or with state 6 and with press 2. Or with This is all of the flip-flop number zero equation, and we will change it to the variable like this. This group is the state zero and with phase zero. This is group number 2. Number 3, this stage 2 and this phase 1. Next is stage 3 and with phase 1. This is a group of variable of this equation. Next is the state 4 and with phase 3. Next is state 5 and with phase 3. Next is state 6 and with phase 2. And the last one is state 7 and with phase 2. This is all of the flip-flop number 0, all of the equation of the flip-flop number 0. And next, go to the flip-flop number 1. Flip-flop number 1 focus in the third digit of this. Flip-flop number 1. Flip-flop number 1 is the state 1. And with no place, I give the no place is n. Or with state 2 and with the no place, or with the state 2 and with phase 1. Or with the state 3 and with the phase 1. Or with the state 5 and with the no place, or with the state 6 and or with state 6 and with the no place, or with state 6 and with phase 2, or with state 7 and with phase 2. And I will change it into the variable first of this group. I will change it. This is the first group, state 1 and with no place, or with state 2 and with no place. Next is and or with the state 2 and with phase 1. Next is state 3 and with press 1. Next is state 5 and with no press. Next is state 6 and with no press. Next is state 6. State 6 and with press 2. And the last one is state 7 and with press 2. This is all of the fifth of number 1 equation. Next, I will go to the fifth of number 2. Fifth of number 2 is focus on the one on the second position of one in the state level. But I will write it in this variable form. I not write it in this to make it faster. F2 is the state 3 and with state 3 and with state 3 and with no press. State 3 and with no press, or with state 4 and with no press. Or with state 4 and with press 3. Next is or with state 5, or with state 5 and with the state 3. Yeah, or with state 5 that and with state 3. State 5. Oh, sorry. Or with state 5 and that and with press 3. It's not state 3, it's press 3. Or with state 5, or with state 5, next is or with state 5 and with no press. Next is or with state 6 and that and with no press. State 6. Next is or with state 6 that and with six the button number 2 the press 2. And the last one is or with state 7 that and with press 2. This is all of the equation. This is all the equation of fifth of number 2. And the last, fifth of number 3. From state table, we got the state. First is the state 7 and with the state 7 that and with the no press. Or with the state 8. and with the no press. This is all of the equation of flip-flop number 3, and I will talk a little bit about the middle block. And from the state table, we have 4 flip-flop. This is a middle block. We can calculate the middle block by observe the state diagram, amount of the state. We have 0 to 8, so we have 9 states. We cannot how to calculate is 2 power amount of the flip-flop. That's why we use 4 flip-flop, because 2 power 4 is 16, so we can design it in this 4 flip-flop. That's why that's my middle block. That's all. This is my digital lock key circuit. Next, I will go to the state of test vector table and simulation. This is my test vector table in the left. Go to the vector simulation. At the first clock, we didn't push anything, so it's still in the state 0. At the second clock, I pushed the button 0. My first password is 0, so it's correct, and then it's go to the state 1. At the third clock, we still push the button 0, so it's still in the state 1. The third clock, we release the button, so it's go to the next state 2. This is state 0 and state 1. This is state 2. At the fifth clock, we push the 1. Number 1 is my second number password, so it's correct, and then it's go to the state 3. And at the 6th clock, it's still in the state 3 because it's I still push the 1. And at state 7, at the 7th clock, I release the button, so it's go to the next state. It's state 4. And then at the 8th clock, I push the other button, so it's go to the state 0 because it's wrong. And next, the ninth clock, we release the wrong button, so it's still in the state 0. At the 10th clock, we push the button 3, the 3 button, and it's still state 0 because it's wrong. The first password is the 0. And at the state 11th clock, I release the button, so it's still in the state 0 because the before is wrong. And next at the 12th clock, I push the button 0 and it's correct, so it goes to the next state. And when release it at the 13th clock, it goes to the next state. And at the 14th clock, I push the button 1 and it's correct, so it goes to the next state. And then I release the button at the 15th clock, so it goes to the next state. And at the 16th clock, I push the button 3 and it's correct, so it goes to the next state. And at the 17th clock, I release the button, so it goes to the next state. At this is my state 6, and at the 18th state I push the button 2 and it's correct, so it's go to the 7th state, state 7, and at the 19th clock I release the button, and when I release the button it's go to the next state, and and it's the state 8, and in this state the LED is on, so output is the on, and at the 20th clock I push the author button, so it will reset the digital lock key, so LED is off, and this is all of my digital key lock. Thank you very much for your attention.